Hi everyone. So in this video I'm presenting my library Hocrox. So I've been working in this library for last around 2 months. So Hocrox is basically image preprocessing and augmentation library. It provides a Keras-like interface. So in Keras we usually use a certain syntax, certain high-level APIs to make models. So Hocrox also provides some similar APIs. I mean it looks similar for making pipelines for pre-processing and augmentation pipelines. So first of all, if you don't know what pre-processing is basically a process of formatting the images and tweaking the images in certain ways before we use those in some machine learning models. So for example, if you have a bunch of color images, we can grayscale those images or maybe normalize those images before we use those in a machine learning model. Similarly, image augmentation is basically a process of increasing the image basically by slightly modifying and tweaking the images. So for example, if you have, let's say, an image of a cat, and if you randomly rotate it to a certain angle, maybe zoom it a bit, and you create 5 different copies of it, then we artificially increase the amount of data that we have. And also, as in machine learning, generally if we have more data, then the model performs better. And also in this case, the model kind of knows more data. It is more robust because it's seen more type of data, so it usually performs better most of the cases. So at this point, if you're thinking like, okay, why another like image augmentation and preprocessing library? There are like so many of these. So basically, Hocrox, I mean, I just created, to be honest, for fun. It's no way like it can we cannot like compare this with like some big image augmentation libraries, but still it's provides like a Keras interface, so it's very simple. It's, as I said, it's very simple, so it's easy to learn. Also, it's extremely flexible. That means you can actually create custom layers and you can use it in the way you want. And also it uses internally OpenCV and NumPy, so it's incredibly stable. I mean, and also, as you know, OpenCV and NumPy both are like incredibly optimized. That means it is also optimized. So let's write some code then. So the first thing is you need to get some images from online. So I already provided a link here, where from this link you can download 5 images. This is a Google Drive link. So once you have the image, and if you generate, if you just run this line of code, you should have an images folder, and inside that folder there should be 5 separate images. So once you have the images, the second step is basically to install Hocrox. Now I'm not detailing the installation instruction here, but just check the documentation. This is the link here, and you can see the documentation for installation instructions. Once you have the images and install the the necessary libraries, then you can actually go and import the dependencies. So first here I'm importing the model. So model is basically the base class. It's the main class, and if you use Keras, it's similar to the sequential class. After that, I'm importing read and save. So this is from layer. So read is, as you guess from the name, it's basically used for reading the images. Similarly, save is used for saving images. After that, I'm importing from layer.preprocessing.transformation resize. So when you download images from the internet, it's like all of different sizes. All the images are of different sizes, but in a machine learning model, we usually need to all the images to be of same size. So that's why you can use resize to resize the images. After that, I'm using augmentation.flip. I'm importing random.flip, which flips the image randomly. Similarly, I'm importing random.rotate, which rotates the image randomly. So let's import the dependencies. After that, you need to initialize the model. So it is similar to in Keras, we used a sequential. Here we're using just the model class. So once you initialize the model, then the next steps are to add the model. So first we are adding the read layer. Now in read layer, we're passing the path as images. So because this is the folder where all the images are, and we're just calling some name. This is optional. If you don't pass the name, it's fine. It will just auto generate. After that, I'm adding the resize layer, where I'm resizing all images 2 to 4 by 2 to 4, and similarly I'm calling it's something, it's optional. Similarly, interpolation is also optional. After that, I'm adding the first augmentation layer, so random rotate, so it randomly rotates, and I'm passing a range, start angle and end angle, so it will rotate between these angles. And also I'm passing probability as 0.7 and number of outputs as 5. Now this number of outputs, so initially we just have like what, 5 images. So number of outputs, what it will do is it will for each images it will generate 5 separate copies of it, and then it will apply some, so in this case it will rotate the image randomly with a probability of 0.7. So because of this there will be 25 images, 5 times 5, 25, and for each image there is a probability of 0.7. That means 70% of the chance that that image will be transformed with this layer. So after that I have another layer, random flip. Now here the probability is 0.7, but there is no number of outputs. By default the number of outputs is set to 1. So till the end of this layer we'll have 25 images. Here as the number of output is 1, so we'll still have like 25 images, and the probability of 0.7, so there will be 70% chance for each images. On each images and I mean we will apply, there will be a probability of 0.7 to apply like this layer. After that we have the save layer. So this is like saving the images, so we are saving this in this particular folder that I already created. And also we have we can set the format. So there are 2 supported format as of now. One is img image, so it saves this as a normal image, and npy, that is it saves it as an array. Similarly I'm passing some name here, so let me just run these 2 cells. After that you can generate a summary, so it just generates a summary of the model, so you can see like what you did. Once you generate the summary and okay, you can call model.transform to transform the images. Once you transform the images, you will see first of all is these are all the images, and there are 25 images. Okay, and initially there was 5, now 25, because we, as I said here, the number of outputs is 5, so 25, 5 times 5. And each image is, as you can see, there is some random rotations, it's might be flipped, everything is a resolution 224 by 224. So yeah, that's the basic the code for running a simple, like making a simple model. Now I'll attach this link to this Jupyter notebook in the in the video. So yeah, thanks for watching this video. Also I'll attach this presentation with, I mean a link to this presentation with the description, so you can see it there. Thanks.